Hello everyone, you're welcome to this channel once again. Today we have another question from spring mass damper system. Now let's read to the question given to us today. The displacement of the vibrating system, damper system, is recorded in XY plotter, reproduced in figure below. The Y coordinate is the displacement in centimeter and the X coordinate is the times in seconds. From the plot, calculate the undamped natural frequency. Once again, the displacement of a vibrating system mass damper is recorded on XY plotter and reproduced in figure below. The Y coordinate is the displacement in centimeter and the X coordinate is time in seconds. From the plot, calculate the undamped natural frequency. Once again, calculate the undamped natural frequency, which is WD, Wn. Now, we're told that the response of a mass spring damper system gives us this particular sinusoidal plot. Now, looking at this particular plot, we have the first peak, which is x1 here, which is 0.75 centimeter. And we have the second peak, which is x2, which is 0.20 centimeter. Now, by using the formula of natural logarithm of the ratio of two peaks of a response, which is delta equals natural logarithm of x1 over natural logarithm of x2. That gives us natural logarithm of 0.75 over 0.20, which gives us 1.32. And don't let us forget that the respective time difference variation from the point of two peak equals t 4 seconds. Now that we know that the time taken for these two peak is 4 seconds. Now, by using the formula of frequency to time, which is F equals 1 over T, that gives us 1 over 4, and which resulted to 0.25 Hertz. Now, by calculating the damped natural frequency of this particular response, we use WD equals 2 pi F. So by slotting all our value for this particular equation, WD becomes 2 to the product of 3.14 to the product of 0.25, which is calculated. So our WD equals 1.57 radian per second. Now that we have found the damped natural frequency, the next thing is to find the undamped natural frequency, which is Wn. So by using the particular equation, WD equals Wn to the square root of 1 minus the ratio of the damp, that is the damping ratio, squared. And how do we calculate damping ratio? Damping ratio equals delta over 4 pi square plus delta square root. So that gives us 1.32 over 4 multiplied by 3.14 square plus 1.32 square, and that gives us 0.2067. Now that we have found the damping ratio, which is zeta, the next thing is to find the undamped natural frequency by using this particular equation again. WD equals WN to root of 1 minus zeta square. From there, we can deduce our WN equals WD over 1 minus zeta square. That gives us 1.57 to the root of 1 minus 0.2067 square, which eventually becomes Wn equals 1.6047 radian per second. Thank you.